great discussions. All right, folks, this is great. Thank you all so much, and welcome to our webinar here. I hope you're enjoying things. It's chemical inventory, fire code, and U is the U, I believe, right? And I thought about how do I do my own intro here, and if you're old enough to remember, Admiral James Stockdale in 1992 was running for VP, and he came out on stage and said, "Who am I and why am I here?" Because of course no one was recognizing him, and got skewered very much for that. I actually had to look it up and make sure I had the names right and all of that. He and Perot were the independent third-party candidates. But some of you know me, some of you don't. For those that don't, I'm Jonathan Klain. I'm our Director of Risk Management and Safety Education, mostly behind the scenes, doing mostly content type stuff. How do we help the community? And part of that is helping with these community webinars. I've been a panelist several times. And so as you can tell, I'm not Matt, who is our typical MC and host and moderator. And Matt is on a very well-deserved vacation. The guy has not taken a vacation in I don't know how long, and he has been just wonderful at shepherding and putting on and hosting these webinars. And so he's on vacay. So I'm stepping up to the plate here and taking the reins. A little bit nervous, but I've got such a wonderful crew, both behind me, behind the scenes. A shout out to my colleague and cohort, Chris Richards, who's my backup, and wonderful, wonderful colleague here. So much fun. And then of course to our wonderful free panelists. So I want to, of course, have us welcome our panelists, and I'm going to turn it over to them and ask each of them to give us just a brief intro of who they are. I guess I should say, for those that don't know me, my background is EHS, whole bunch of initials that I'm pretty sure no one really cares about, whole bunch of different roles and projects that I can't even remember at this point, and a number of years that I'd just rather not say about being in the business, but really very happy to be here. And it's a wonderful role here at bio-raft, and just thrilled. All right, so with that, I'm just gonna go in the order down the screen as I see you guys, and I'm gonna stop sharing my screen so that people can really see us all in a bigger way. How's that? Hopefully that's better for everyone. All right, so from my screen, I've got John. Do you mind doing an intro first? And then I'll go to Jeff, and then lastly to Lenny. John, are you muted? We love technology. It's a wonderful thing until it doesn't work for us. Oh, I think I heard Lenny. Let me know if you want me to start with the others, John. Just give me a nod. Yeah, I will. All right, Jeff, do you mind? And John will figure out his audio, I'm sure.
Okay, so my name is Jeff Foisel. I'm the Process Safety Technology Leader for Dow Chemical Laboratories for the Research and Development Group. Chemical engineer by degree out of Grove City in Western Pennsylvania. So nice to see some of the Pittsburgh and Pennsylvania people on the phone. Currently live in Midland, Michigan, and I've been doing laboratory safety, facility design, both locally in Michigan as well as all around the world for about the last 25 years of my career.
Wonderful. That's great. Thank you very much, Jeff. Lenny, please.
Thank you. Yeah, glad to be here. My name is Lenny Farello. I am the Risk Engineering Manager for Intel Corporation. I live in New Mexico. This is my second tour with Intel. I started my career at Savannah River site with Westinghouse years ago as a contractor, did that 5 years. Moved out here to Rio Rancho, worked for Intel for 12 years as a site fire protection engineer here, managing their program. And then for 11 years, I was with DOE, the Department of Energy, with the nuclear weapons program, managing their corporate program. So I'm back to Intel about a year and a half and managing their fire protection and risk engineering program, and look forward to supporting this panel today. Thank you.
Wonderful. Lenny, thank you so much. This is great. John, are you with us?
Well, let me find out. Am I with you?
Yay!
All right,
All
good.
right.
Unplug it, take it apart, clean it, put it back together. That's the way it always works. So I'm John DeLaHunt. I'm the risk manager and the fire marshal for the University of Texas at San Antonio. I've been here for 13 years in this capacity. Prior to that, I was the environmental health and safety manager at a small private liberal arts college in Colorado, where I did everything from asbestos to x-rays. And if there was a Y and Z in health and safety, I'd have done those things too. But my first gig was helping understand how we apply fire codes to new construction, because it was a new, the hazmat regs were new in 1988, 1989. So since the beginning of my career in higher education, health and safety, I've been negotiating the interface with laboratories and with fire codes. And I am an alternate on the NFPA 45 technical committee. So I actually now get to help write those codes, which is a great honor for me.
Yeah, that's wonderful. And I was just thinking back, oh my God, I think at about the same time I took my first 40-hour hazmat course as well, which was very interesting. Worked for an environmental engineering firm at the time. And John and Lenny and Jeff and I have had a great time discussing all sorts of things and what do we want to talk about today. And we will be talking very openly. This is for purely educational purposes. John happened to mention that he and Jeff are on a committee, I believe, together. Lenny's been on other committees as well. I've been on other ANSI committees as well. I think a lot of us understand that. So needless to say, however, I'm going to say it anyway, what we are contributing is not representative of the committees that we are on, nor is it necessarily representing the views of the companies that we represent. It's for educational purposes. It is not for code compliance or other direct advice to people. But we are very happy to all be here and engage in a wonderfully open conversation and try to help everyone understand what is this intersection really between our chemical inventories and fire codes. And they're the experts. So let me get to those questions. Unless I left anything out and you want to add to the legalese disclaimer and all of that.
Nope, you got it covered.
All right, awesome. I try as much as I can. All right, so we talked about a lot of stuff. And one of the things is really not purely the response, but really in the design. And in particular labs, which have a lot of chemicals, although other processes do as well. So I want to ask the three guys, we'll do them one at a time, and feel free to interact, of course, guys. So, but with the lab design and the operation of the labs, how does that relate when it comes to risk and what we're talking about with the inventories and the fire codes? And feel free to take it in whatever direction you're most comfortable in. And who wants to start us off, guys?
Well, I'll go ahead and give it a shot. I think that there's a concept out there called the maximum allowable quantity, which is really not the maximum allowable quantity. It's a threshold. And if you pass that threshold, there are expectations that your building will have additional fire protection enhancements. And those additional fire protection enhancements are massively expensive, usually, and difficult to implement and difficult to maintain. So architects will often seek to create a building that is easy to build, easy to maintain, easier to build, and easier to maintain, cheaper to build. And the result of that is that there's an inherent limit to what you can have and hold in a laboratory space or in a portion of a building, and it's that threshold, that maximum allowable quantity of that threshold. And exceeding that is an operational question. So the designers will say, these are the control areas, these are the fire boxes in the building, and the limits are the limits based on areas, levels above grade, and number of control areas, and blah blah blah. They'll come up with numbers, and then they'll pass those numbers off. This is the way it works in higher ed. They pass the numbers off to the chemistry department, and then the chemistry department shakes their head collectively, crying, weeping over the limit of sulfuric acid that they're allowed to have on the 8th floor of the building. And then complain that it's impossible to run an analytical lab on the 8th floor of the building with this little sulfuric acid or this little solvent. And we all say, well, I'm sorry, but that's the way it is. So that's my view or my experience with this. It takes a great deal of effort to create a high hazard space inside an academic building. You have to be very diligent and careful about how you do that. It's very difficult to do that high above the grade level, and it's very difficult to do that underground. It's something that really needs to be thought through in terms of what problem are we trying to solve. So often architects will say, we want a great big laboratory on the 8th floor. And I'll say that great big laboratory on the 8th floor has to be attacked by firefighters in protective gear walking up the stairs with hose packs. And if that's not you, then maybe you should move it down to the 1st floor where they can attack it more easily.
Yeah.
So there's this dynamic between what the users want, what the architects want to achieve, and what the university wants to pay for.
Mhm.
And often what we end up with is we just end up with the cheapest thing we can get, which is threshold, the maximum quantities, and that's all you get, even if that creates operational limits. And then it's between the fire marshal and the occupant to work that out. So that, to me, John, that's how the design interfaces with reality.
Yeah, good. That's a great start, John. Thanks. Let's see what the other two guys.
So,
Jeff,
just jumping on, just jumping on a little bit on what John was saying. First of all, that's not limited to just academics. The exact same scenarios applies in industry also, where yes, it's very expensive to build high hazard areas, and it's very expensive if you have to go up or down below grade level. So absolutely true everywhere you go, because largely the standards are the same standards that are out there. One of the things that I think I'm going to take the question just a little bit different way to add to what John was saying. I think there's a little bit in there about, sort of where do these standards come from? And in terms of trying to establish that baseline concept of things, those quantities came about a long time ago, because basically what the intent is to try to show that if there is a fire, that number one, first and foremost, everybody can get out safely. And number two, the damage of that fire would be limited to that one lab unit, lab fire control zone, whatever the particular code that you're looking at, but basically to try to not lose the whole building, but just lose that one little zone. So part of the economics there is to make sure that, as you're looking to establish these laboratory units or the fire control zones and where these are, is realize that that's the zone that literally would be sacrificed if there is a fire, but it's not going to go beyond that point. And that's where the standards themselves are coming from, to try to limit those maximum quantities so that they will still meet the design parameters to allow no loss of life and limit the damage to one zone.
Yeah, great, thanks. And I think we all understand that industry has a lot of the same, or at least similar challenges. Lenny, what about you, your perspective? What would you like to add?
Yeah, so talking about, the requirements, each industry has different requirements. Each jurisdiction has different requirements. And so wherever location you are, you need to determine what the requirements are, right? As fire protection engineer, we flow down the requirements. When I was with DOE has orders that flow down and dictate what we're required to do, right? There's no local jurisdiction. The government is self-insured per se. At Intel, we rely on, many different states and country jurisdictions around the world. And so we need to understand what the high level codes are, and flow those down so we understand what our requirements are. And typically in the States, it's the fire code, it's the building code, and it's the NFPA code. But to design and install and construct, a lab or a building, you need to know what codes you're under. As we know, there's different years. We need to identify those. Identify the codes of record, and make sure that jurisdictions are accepting of that, and then get those to the architects and the A&E companies so they can design us the right facility moving forward.
Awesome, great. Cool, this is great. Let's do another one, and then I've got some specific questions for each of you that I think will be very helpful as well. So why don't we start to get into some of these key features? And so what are some key fire protection features for the lab occupancies? And feel free to go in any direction that you would like, guys.
I'll start again on this one.
Sure, thanks, Lenny.
So, as we talked about NFPA, with labs, NFPA 45 is kind of the resource for labs, and you can flow down through there and it kind of talk you through the high level features. As a fire protection engineer, we're always interested, of course, in suppression, sprinklers. So those labs, typically require sprinklers, and depending on the lab, the type of lab, the class of lab, the sprinkler design can be different. Again, about the building codes. The building code and NFPA 101, those are two codes that have to be looked at when we're setting up labs. There's a little bit of differences there between occupancy types and those types of things. We need to take in consideration, fire alarm systems. The building itself has to have a fire alarm system. In some cases, with high hazard operations, we may want to do detection in those rooms. It just depends on what we're doing. Life safety, you can either use the building code or NFPA 101, but horns and strobes, manual pull stations, emergency lighting, secondary exits, those type of things. And everybody here is familiar with exhaust requirements for labs. That's a key important equipment for, chemicals. The other thing is flammable liquid storage cabinets to house our chemicals while we're there. There's some requirements for signage, lab signage on the doors, fire extinguishers, typically, dry chemical extinguishers, but in electronics labs, we want to look at clean agent types of extinguishers. And then some of the planning stuff, we want to have procedures for fire protection and also emergency response plans in case something happens. The two things I wanted to mention here that are really big on risk management and insurance programs, our hot work program. We need to have a hot work program for the lab and for the facility, for the location, and then impairment program for your sprinkler systems. We don't want folks operating in these rooms if the sprinkler systems are down. So those are two key, property insurance programs that will significantly decrease your risk.
Cool. Great. And actually, that was the question I had wanted to ask Lenny. So I'm glad that Lenny realized that and started with it. So I'm going to do the specific questions for the other.
Actually, can I add a little bit onto that, Jonathan?
Oh, sure. No, of course. Absolutely, Jeff.
Just looking at some of the questions that are showing up in the question and answer portion there.
Yeah.
And I think this builds nicely with what Lenny just said.
Okay.
One of those key parameters, in addition to everything that Lenny mentioned, just want to really highlight the idea of just the construction itself. And this is where you start getting into the definition for what exactly is a fire control zone. And a fire control zone is the terminology used coming out of the ICC, the International Fire Code side of things, whereas laboratory unit is a similar concept, but it's coming out of the NFPA 45 side. In both cases, that area is defined by where your firewalls or fire separations are located. So if you have, depending on the particular code, you may be allowed a limited number of those things. IFC is going to limit you depending on what elevation you're at and the size of those things, but it's basically going to be determined by where are those walls constructed. And then within those walls, that would become then a laboratory unit in NFPA 45 or a control zone. NFPA 45 goes further and actually calls out laboratory work areas, which is things that are still within the same boundary of firewalls that are there. And those firewalls, you can vary everything from a 1 hour firewall or even a non-rated one in some cases, right up through like a 2 hour firewall, which will get you a much, much more higher rated, larger amount of solvent that could be effectively managed inside that.
Cool. Awesome. Thanks. All right, let's try to do the other specific questions here. So John, let me ask you this one. So the four of us talked about the need for a integrative management of change. And this is an area that I know that you have a lot of experience with and passion for. And maybe you could talk about, what your recommendation is for how to use what that is. You may have to do just a little bit of explaining for the audience and contextualizing when it comes to this whole issue of space use and planning, because you can't put chemistry labs on the 8th floor and expect things to go really well. So maybe you could talk about that and its direct benefits for a couple of minutes.
I'd be delighted. Anyone who works in higher ed knows that the knives never get sharper than when space is on the line. So space is everything. It's the currency of higher education, especially for the academics. So there's an inclination among the academics to keep the space that they have and try to accumulate more and put people into the space that's open rather than spend money to put them into the right space. So for instance, we had an opening in mechanical engineering, and we hired a fella who does stuff with rockets, and we're in South Texas near SpaceX, and so it's important for us to be close to rockets. which is great. But they thought he was in rocket design and sort of flight mechanics, because that's what I guess it's what they thought. He gets here and we're putting him into a lab that's got a fume hood. It's got a little 4-foot fume hood. So clearly it's an old prep lab. And it turns out what he does is he creates sensors that measure the gas components of rocket exhaust. And so he has to create simulated rocket exhaust in his lab and then shoot lasers through it and figure out if his sensors are actually reading correctly. And so clearly doing this in a prep lab is not a good idea. So the conversation that happened with the associate dean after we moved him was, we should have had you guys at the table during the hiring process. And this is management of change for me. This is the essence of this. We have research programs that change. We have faculty who change. We have the things that we teach in organic chemistry change, not a lot, but sometimes. We might have a space that is undesignated and then later it gets designated. So we had a shelled out lab in our science and engineering building, and we hired a researcher who does synfuel, and they basically mix methane, hydrogen, and carbon monoxide at high temperature and high pressure to make gasoline. And that's a change to the program of the building. We have to account for that. We have to make sure that everybody knows what's happening there. So to me, the challenge is to get the fire code conversation engaged with the academic, the hiring conversation, with the pedagogic conversation. What are we teaching and why are we teaching it? And then you have to deal with the academic freedom side. Now, this is something that perhaps the industry guys don't have as deep a sense of, but the academic freedom side is the faculty who have tenure sometimes believe that that tenure gives them allowance to do anything they want. And it ain't necessarily so, but we have to have a process to manage that change, because ultimately the university and the community will pay the price of a failure.
Yeah.
And so really what my ideal is that we are engaged in a process. We are changing all the time, but we understand that we're changing all the time, and we're understanding all the factors that weigh on that change, and we're asking the right people the right questions at the right time, or perhaps early. So that's, for me, management of change is that's the panacea. If we ask the right questions at the right time of the right people, we'll end up with a much better result.
Yeah, absolutely. And Jeff or Lenny, if you wanted to chime in from the industry perspectives, I know we've talked about this amongst ourselves, and share again. I think these things are not limited to academia. They're very broad scale. Certainly feel free right now. Is it been your experience too that there's really a tremendous amount of work? Because I can remember, just my quick context, guys, when I worked as an embedded safety director, the best outcomes were the ones where we involved everyone that needed to be right from the start before the new PI came on board. And we had to work hard to figure out what's the best space for not just that person, but that lab group, but as John's saying, the research going on. So is that a challenge for you guys at your operations too?
From the Intel perspective, I think Intel does an exceptional job at the medium and large type projects. We have a really good process for that. I think sometimes when you get these smaller, like off the cuff modifications to labs and those types of things, sometimes they run under the radar and maybe not get the right technical support per se. And so, we try to work on getting in front of them early, or educate them that we're available to help. But all the parties need to provide input on those types of things, because they get further along and they're ready to occupy the lab or take over operations, and then we come in and they're not real happy, and they don't have the money. So it's always better to kind of promote yourself and your support and your willingness to help, and upfront, and have them use you instead of getting involved too late when they don't have money, and then you're the bad guy, right?
Yeah. Jeff, I got a question for you. As we're talking about this, we're really talking about inventories and how it affects fire codes, and how fire codes are written to deal with a lot of things, including the chemical inventories. So from your experience, how do you work on trying to help everyone recognize this and control and manage the actual quantities, so that as John's saying and Lenny's saying, we all know, you're not running into these, oops, we're trying to build a lab on the 8th floor of a building or, in an industry a little bit different.
Yeah. Okay. So best ways that I have seen to try to manage these things. First of all, like Lenny and John are saying, the engagement of everybody is really essential. And a lot of times I've also seen that just trying to understand, I think, John, you mentioned real early on, the fact that there's, depending on the building, it might be built under a different year, which could be a different code requirement. So you might have something that was built under the old universal fire code, like back in the 1980s, which would then be the governing standard. Something else that was built after a township or a community adopted NFPA 45 could be built to NFPA 45 or to the IFC or to any of a number of different codes that are out there. And sometimes it even applies differently depending on letters of interpretation. For example, some of the buildings that I know about and manage, we have NFPA 45 to control the flammable aspects, but the IFC for the other hazardous materials. So we have different things coming into play. I think there might have even been a question in chat about when you sort of start going from NFPA 1 to NFPA 45. Working with your authority having jurisdiction, your local fire marshal is really essential to just establish what are the quantities that you're allowed in the different control zones. Once you actually have determined that, which would also then include things like your raw materials coming in, your chemical supplies, and your waste are also still included in those numbers. So when you're looking at the total threshold quantity, it's the total amount of molecules that will burn. And I'll just use flammable as an easy example. But what has been very effective is once you find out for that lab unit or lab control zone, which very rarely does a single researcher have that entire zone all to themselves, having the local EHS people divide out the quantity so that everything gets down to a manageable piece that each of the researchers or each of the investigation teams then has their portion that they can manage, which is usually much, much lower than the total quantity for the zone, but in each of the different flammable categories. So having their, the quantity of 1A flammables, the quantity of oxidizers, the quantities of corrosives, all of the different things divided out into the different zones. And then that they can now manage to those numbers and realize that the sum of all those numbers would then still put you within the compliance for the overall fire control zone or laboratory unit. But by dividing it out and getting it down into a manageable quantity that an individual user can have, then all we have to do in EHS is basically play referee so that if this group over here wants to go 1 gallon more, that's fine. All you have to do is get this group over here to get 1 gallon less, and just trying to referee that they can always trade off as long as they're within the same zone because it's the maximum quantity for the zone that's going to be safe.
Cool. Thanks very much. There's a lot of great questions in the Q&A, so we will be moving to that in a little bit here. It's half after the hour, and I'm sure that our trying to answer the questions will go the usual 15 or so after the hour if the guys can stay with us, which we certainly hope. But one of the things that I think that all three of you are touching upon, and I know we talked about it a lot, is this, what are really, from your experiences, some best practices for engaging with your fire service teams, the before, the during, and after actions? Are there certain activities that you've seen used with success? How do you build that relationship to really benefit them as well as the company or institution? And I'll let anyone start here.
I'll start. The engagement of the different groups is really key. I mean, we've already touched on that many times before. So you actually do have not only the fire marshal or the authority having jurisdiction, but you also have the actual responders who are going to be coming in if there's an incident. And you have the researchers, and you have the facility managers, and you have the local EHS people. So there's really 5 groups that all need to be involved. And the one thing I can suggest on that is pizza. Getting some pizzas and bringing everybody together to start doing some talk throughs. If it's in the design phases, getting all 5 of those groups together to sit there and explain, this is what we're trying to do. These are the extra controls we want to put in place because we know we're going to be pushing some of the limits over here on the building design side, but we want to put these other controls in place. Does this make sense to the people who are going to respond? Does it make sense to the facility owner? Does it make sense to the AHJ who's got to sign off on the permits? there's sometimes, actually, there's a lot of times in the different codes where it has alternative methods are allowed if the authority having jurisdiction agrees to it. And so that's getting them all together and having that discussion on that side of things initially with pizza. And after the labs are in operation, inviting the responders in order to have them have familiarity with what's going on. And again, pizza is a necessity on this also, but bringing the responders in order to, have them actually either do paper exercises so that they're aware of the hazards and how those hazards are communicated. And even walking down and walking through the lab areas, sometimes there are some very interesting methods that if they've had a chance to see them ahead of time, they'll know how to attack the fire. If you've never seen that and you're coming into a building cold, oh, that's a lot more scary as a response person,
Sure, absolutely. Lenny or John?
Yeah.
Please.
So adding on to what Jeff said, in New Mexico here years ago, I would actually have the different shifts, the fire department shifts come out, and I would ride around in the battalion chief's car, and the trucks would be behind us, the ambulance, and we drive through the campus, and I would have the headset, and I would talk to each shift about the site. I'd talk them through the site. Where are the riser rooms? Where are the pump houses? Where the fabs are located? Where the chemical rooms are? We drive through the areas and make sure that they had adequate fire lanes and parking and access to hydrants. And so it was just a real good method of kind of integrating with them. And we would do that for each shift, and we would do that every year. And so, drills are a big part. We're all supposed to be doing drills. So we would, from time to time, we would have drills that involve the fire department and have them come out. And I remember one time we actually, shot water off the top of our parking garage with the fire department. And so, just kind of inviting them and coordinating your stuff with them, inviting them for pump testing, inviting them when you're acceptance testing new systems. A lot of times the fire department and the HJs are really too busy, but just making them more aware of what your safety and fire protection programs are made of. You want them to have a good feeling that you're mining the store per se, right? And they don't have to worry about you because you're doing the business. So
nice. John.
I would add to that on the fire ground during the event, it's very important to have somebody who speaks chemistry and somebody who speaks firefighter at the same time. And it may be that you have to have two people there. So someone who speaks enough chemistry, but mostly firefighter, and somebody who speaks enough firefighter and mostly chemistry to talk to each other and sort of get the point across. But in one of our recent events, we had a explosion, injury, fire, flood, $160,000 and near fatality in the exploding glass range. And after the fire, the lieutenant who was on the ladder truck was standing up to his ankles in water and said, "What's happening in this lab, John?" And I said, "Chemistry, sir," because I refuse to be wrong. That's my cardinal rule is don't be wrong. You can be vague, but don't be wrong. The reality is that if we had gotten the PI, who was a Chinese national, to come and give the talk on what was happening, we would have gotten a dissertation at a PhD level. And the firefighters really don't need to know that. They need to know what's the fuel load here? What are the reactives? What are the poisons? What are we working with? And if we put a bunch of water on this, is it going to blow up? And that's the level that we have to have the conversation at. And we have to have I think Len and Jeff are both exactly right. We have to have relationships with our first in engine companies and with our hazmat teams, heavy rescue teams, special ops EMS. These folks are going to come in and work the problem when we have the problem. And that's the last time that you have to make a relationship. We all should be making relationships well before that. At UTSA, we're targeting 2 first in engine companies at each of our campuses for Wednesday morning tours. We're going to every Wednesday at 10 o'clock, we're going to take them around a building, and that's going to get all 3 shifts at all of our campuses. And it's going to be a weekly thing that we do for the fire department to get them familiar with our spaces. You have to cover all 3 shifts. You have to repeatedly cover the land because people change. And they need to know things like where the elevator shutoffs. They have to know that. And if you don't know that they have to know that, they're going to be asking you during the fire, where do I shut off these elevators? And I don't know is not a really good answer during the fire. You really should be saying, those are in the elevator rooms on level 5. Here are the keys.
Yeah,
that's the answer. So these are things that we all as site operators have a chance to get together beforehand, but we have to really reach out and make those relationships, because when the fire department shows up, they're going to be looking for people they know and people they trust to say, what are we doing here? And that's the role, fundamentally, that's the role of the safety office, is to understand what's happening in the labs and speak to the fire department.
Yeah, you know, I'll share very, very briefly. At one of my previous institutions, at both of them, they had clean rooms, big nano fabs, right? And at one of them, we had a local fire department embedded at the university. And so the clean room manager would bring in the different companies and run them through. And he invited me as their safety director to sit in. And I saw exactly what the guys are talking about. You have to make sure that the language you're using is the language that your audience needs. And in this case, there was a little bit of a disconnect. So I played a little bit of that translation part to explain what some of these acronyms were. And I knew what the fire code, the fire department personnel really wanted. And lastly, to John's point, but to all of the guys, it was very interesting when we did the walkthrough, the things they would key in on. How do you shut this off? How do you shut this off? How do you shut down the whole system? And to his credit, our NanoFab manager was like, here is the big button. The big button shuts everything all at once. And they're like, how does it operate? How do I get to it? I mean, it's literally about that. And the more you do ahead of time, it pays off in so many ways. This is great. We have a lot of questions. So I'm going to move, I think, us along to the questions now. And I think the questions are going great. No shock whatsoever there. Please keep contributing, vote them up or down. We'll try to find them appropriately. There's been some good talk, of course, about inventory management systems. And of course, you know, yes, bio-raft does have one. It's called ChemTracker, as there's been some discussion. And so, of course, you can feel free to ask, and please post about any of the systems that are out there. We are very agnostic about that when it comes to this. We want there to be a robust discussion about it. But of course, those people who wish to know something specific about ours, I've seen that our ChemTracker guru, Serena, has been trying to answer those questions as well, which of course is very appropriate. So I just wanted to mention that for those that weren't quite sure. So very good. Thank you all very much. So let's take a look at, guys, I know you've been looking at this. If you have any in particular that you'd like us to do first, that's fine as well. Jeff, you had mentioned you saw Charles's question, and it was more at university level, but you and John are on NFPA 45. And so there's this question, when do you move from NFPA 1 to 45? The question has other parts that relate to other questions. What about control areas? And I did see that someone else asked, can you please explain fire control zones there, and maybe a little bit on the MAQ calculation. And really that applies to, I think, all 3 of you guys. So Jeff looks like he's got the book out. So we'll let Jeff.
So I'm going to field a couple of things here. Oh, very good. All right, you want this one too then? You know, for NFPA 45, I'll hit the easy one. First of all, NFPA 45 is on a 4-year cycle. So the 2019 version is the current version out there. The next one should be published. It'll probably come out in 2023-ish. Probably early. It's in the process of being revised right now for the committee that's working on it. So that's that portion of things. As far as where to transition them, if you're looking in the NFPA system, NFPA 1 is typically adopted. NFPA 1 does reference NFPA 45. And like we talked about earlier, the idea of NFPA 45 is that yes, the quantities may be different, but there's a bunch of additional requirements in here. And if you go into NFPA 45 and you're adhering and you fit in the scope and you do those additional requirements, the threshold quantities is going to change because we're putting in place more controls on the inventories, on how we're using it, on the ignition sources, on the communications. There's a lot of additional pieces in 45 that were written to give flexibility for a researcher. And so that's why NFPA 1, NFPA 101, NFPA 70 all refer back to NFPA 45. Here's an extra little bonus tip for everybody. NFPA standards you can actually access, and this is not intended as an advertisement for NFPA. I'm not speaking on behalf of NFPA or anything, but if you do nfpa.org/ and then the standard number, you can register and access the free version of that standard number. So www.nfpa.org/45 will get you in there. There's a free registration, but you can actually go through and read the standard, which in NFPA 45, there are sketches in the appendix of what the control zones might look like, as well as tables that cover the building construction and the quantity limitations, and even the container limitations, which are now referenced out of OSHA very closely. So you're going to end up with we never really talked about that in terms of building codes, but there's a whole section in OSHA under portable container management, which does also apply to laboratories.
Cool.
So
All
John,
right.
I've got a quick follow on that. NFPA 1 does not actually define the term laboratory, but it uses the term laboratory, which means that the dictionary defines the term laboratory. That's actually written into NFPA code. So if you're following NFPA 1, the definition of laboratory appears in the dictionary, and I won't read it for you, but I've looked it up. I've just checked. It actually is in the dictionary. And your authority having jurisdiction may or may not agree with that definition. So they may look at something and say that's clearly a laboratory, and you may look at it and say it's clearly a machine shop. And they may say, but it's a laboratory because you're teaching students, and you'd have to have that semantic debate. I just suggest that you ask them to be consistent across all of the jurisdiction. Don't target your machine shop and then not target the community college machine shop. Like if we're going to play by that rule, let's all play by that rule. So that you have to sort of be a linguist when you're in the scope and application sections of these codes, because you have to understand what the words mean, they matter. But after that, absolutely, Jeff is right. If once you are what everyone calls a laboratory, you go to NFPA 45 and basically don't come back.
And let me make sure to finish out on Charles's question. He also writes that also NFPA 45 stopped using postgraduate in the definition. Do these now fall under lab units or industrial? And I don't know if that question gets at exactly what you were getting at, John. I'm not sure on Charles's wording there.
So this is Lenny real quick. In NFPA 101, it class A, B, or C lab is classified in 101 as industrial. And so, I think again, back and forth between NFPA and IFC, there are some differences, but in NFPA 101, it does specify that it is industrial occupancy if it's a B, or C lab. The other thing I wanted to add to this discussion was about the codes again. There's so many different years of codes. There's so many different years of fire code, building code, NFPAs. Back to the jurisdiction, you really need to know, what the jurisdiction is requiring you to comply with, right? New Mexico, we're always 3 or 6 years behind, the ICC, and so, your state may be a little better than that. Some states have their own building and fire code. They have some supplemental information in there. But before you do any project, you need to know what code you're under, what version of 45 you're under, what version of 101 you're under, and they could be different. So just be aware of that before you start down the path of designing.
Yeah, and it does seem, I will be the first to say, look, I'm no fire control expert, know enough to be dangerous, put out a couple of fires, but that's about it. But as I started to work so closely with the various fire prevention people and fire marshals and the engine company people and hazmat, I just learned a tremendous amount. And the various codes, the NFPA codes, the international building codes and international fire codes, there's just so much there that the fire marshal office was always my first stop whenever I needed help with that. And I think that's the main thrust of what we're talking about here, is the advantages of reaching out early and often, helping them to help you and asking for the help way before is, I think, one of the best practices you can adopt. And I'm pretty sure the guys would all agree with that.
And I think that even gets into one of the other questions I saw go through on the chat in terms of the question. I think there's when you have a building that's so old it predates the International Fire Code or NFPA 45, which I work at Dow, which has been around for like 140 years or something. So yeah, we have buildings that are not quite that old, but pretty far out there. And that goes back to that relationship, understanding, if we don't have a copy of that code, have that conversation with the authority having jurisdiction to understand, what is the design basis and what is the safe levels you can have in that building. And getting that understanding in place is so key, because they're the ones that are, if you have to make a modification or change something, you have to know where you're starting from. You have to know what that design basis is.
I'd add to that, you need to have that conversation with insurance, and you need to have that conversation with your first in engine companies. So sometimes the authority having jurisdiction is different than your first in engine companies, your fire responders, because ultimately the fire responders are going to make a decision on the fire ground at the moment of impact, whether or not they're going to offensively or defensively take on that fire. And it's going to be predicated on whether or not they're confident that everything is squared away and copacetic inside the building. Firefighters are done with the time of just running into the fire and no mask and no jacket. Let's wrap the research product up in a turnout coat, run it out through the fire. That just doesn't happen. They're just not going to go in without 3 levels of corroboration on what's happening in that space. Yeah. And if your lab's on fire and you can't provide corroboration, you're just going to be standing on the street watching it burn. And there's that's a conversation that needs to happen with first in engine companies, with the people applying the code, with the insurance folks, with the occupants. And someone has to broker that. Guess what? It's the safety office. Nobody else cares. We are the ones who are going to have to do that. So that's it. It's a big problem on how we're going to get that done. We're trying to work through how we classify our 1974 laboratory building before NFPA 45 was adopted, before there was a state fire marshal's office doing a lot of work, and in our state. They're the ones who are going to be asking us to classify it, so we have to work it out. And that's exactly what Jeff is talking about. You have to sit down with people and make sense of it, but invite the first responders, because they're the ones who are going to be putting their butts on the line trying to save your building and your lives. Yeah,
I bet. And Lenny, did you want to add further to what this is about?
I'll pass on that one. Yeah, I don't have anything.
Okay, no, it's fine. Yeah, we've had a lot of great discussions. It's really good. Yeah, I've just had wonderful, positive relationships with the various fire protection and response people. The more I could do to help them, they were just so receptive to it. It was really great. This is, let's start with a basic one. So we have one, Marcy was asking what defines a fire control zone. Whoever wants to take that softball, feel free to go for it. But then I think we'll quickly translate to Chris's question, because I know it relates to it. If any of you have experience with a project to renovate a B occupancy. So we'll have to do a little helpful explanation, guys, to meet the standards of an L occupancy. I thought it was going to be H, so what the heck do I know? And is such a project even feasible instead of just replacing the building? So maybe a little bit on the fire control zone, what exactly that is, and then this whole issue of what the occupancies mean. Who would like to start?
So on the fire control zone, I tried to answer that one earlier. So I'm going to go real quick on this. Fire control zones just basically defined by where are your firewalls, fire separations. It's wherever those are. You could have multiple rooms inside, might just be one room inside, but it's based on where are those separations. And I think I saw another question in there. Yes, doors need to be shut. And if you're looking to try to find out how a fire door is rated, typically if you look at a door when, like on the hinge of the door where you open it, on the back side of the door and on the frame, the part that would be obscured by when it's closed on the hinges, there should be a little plate in there that would actually have that information as to what the rating is of that door, at least very often that I've seen.
What about on the renovation? Does someone want to try to tackle that? And if you can do it briefly, that would be awesome, but we'll see how it goes.
I'll be happy to, unless Len wants to take a shot.
No, go ahead.
So L occupancy is a California Fire Code provision, and it's basically it's a 6th kind of hazardous material occupancy. I think now they're moving it to calling it H6, but I'd have to check. But the idea is that it's a hazardous occupancy and you have to deal with it as a hazardous occupancy. So converting a B occupancy or business occupancy to an L occupancy is going to require perhaps require even some structural changes. If the B occupancy is not fire separated and the L occupancy is going to be a new occupancy, you might need to create fire separation barriers. That means strip the walls down to studs and put up new sheetrock. And that you'd probably be doing that anyway. But that's certainly one. Adding sprinklers, adding alarms, spill prevention, flooring, all kinds of requirements. It's all possible. And the real question is whether or not you like the bones of the building. So if you like the bones of the building, then strip it down to nothing and start over. We did that. And we ended up with a great chemistry lab. But the alternate is if the building is worn out anyway, if you're talking about a 75-year-old B occupancy, trying to convert that to a new L, I think it's worth just demolishing the whole thing and starting over. That said, if it's historically significant, you probably can't demolish the whole building and start over. So just go find some donors.
Yeah. Oh, yeah. That's always good advice. Talk to the development people if you know what that means. Okay, we're going to launch a poll now, as we always do, about what topics would you all in the audience like to see us do. So my associate Chris is going to launch that poll next, if it's not showing up for you all. There we go. Thank you, Chris. And so please fill that out. We have some various things there. Which topics are of most interest, and are you interested in being a panelist? And this is, of course, just for the audience. I, as a host, and our panelists can't vote on it. It's just the way Zoom sets it up. But this is going great, and I think what we're going to do next, guys, is we will continue with the questions. The audience has been wonderful. We've had up to about 250 folk, and we still have a bunch hanging in there. Let's see how many we can get to in a good way. It's not number, it's quality as well, before the hour ends, because we always lose people there, but we love how much support we get from the audience. And so please, audience, do the poll questions so we can really get your input on these. This is a big part of how we make these decisions. Who do we reach out to, and what are the topics that we really go for the most? And I'll let Chris manage when to take down the poll. So guys, there's been a lot of questions, and you've probably seen them, about laboratory use. We have one from Evan, who is working in a fume hood. Does that count for closed use or open use? I know you guys understand that context.
Oh my God, that's a great question.
Aren't they all great questions, John? Come on.
No, this one is spectacular. It's very, very topical, and it's so spectacular.
We'll go into that, and there's been several questions having to do with waste. How do you quantify the waste? Do they count towards your MAQs, et cetera? And I know you guys know this far better than I. So let's start with the whole, what does it mean by enclosures, controlled enclosures, fume hoods, et cetera, et cetera. And Lenny, do you want to?
I'm going to check to Jeff or Len.
So
no, you all, John, you go to that one. Yeah.
I'll take a stab at it, and John, you can jump in right on top of this one.
Yeah,
here.
you bet.
So, as far as a hood itself counting as closed use or open use, this is not a formal definition from NFPA or anything, but essentially, if there's nothing between you and the molecule, it's open use. So if you're pouring things, you have open containers, you have experiments that are still open to atmosphere, it's open use. If you have a sealed system where you're pumping material and the molecules are always on the other side of something, glass or other things, then it's a closed use system. So if it's open to air, open use. Has nothing to do with the fume hood itself or the particular area that it's being used in. It's all about the apparatus and the containers that the flammable materials in. And the follow-up question that I think I see in there from Richard, just to jump on that one before I hand it back over to John, is a hood considered a flammable cabinet? No, a hood is not considered a flammable cabinet. For that matter, there's even things out there saying do not store chemicals in fume hoods. Now, there might be some times where the hazards are just so great and the transferring them back and forth between flammable cabinets increases the hazard. That's the conversation you'd want to have with the responders and authority having jurisdiction and EHS to get the right risk profile in there. But you don't want to be storing chemicals in a fume hood. That'll typically just, number one, mess up the airflows. Number two, that's where you're more likely to have an incident. And if you have an incident where everything's stored, you have a lot more material involved in that incident. So you don't really want to store them there. And you always want to try to minimize the waste. So there's actually some other things that you're going to run into on like 4-liter waste bottles. If that's truly a bottle, like a glass bottle, and flammables, you're over the container size that you're going to be looking at for a glass container. So you're probably going to want to look at a different like polyethylene bottle or something like that. Sorry, a rated bottle, whether it's polyethylene or metal.
So on the fume hood thing, the architects and engineers will like to call fume hoods closed use because the airflow is constantly moving the material away from the occupant. Jeff and NFPA 45 committee and I all agree, and this was actually settled recently in a vote, that if the material is outside of a container, it's open use. And if it's inside a container, then it's closed use or storage. So an aerosol spray, for instance, is that open use? Well, it's open use when you start spraying it, and it's closed use until then and after then. So during the period of spraying, it's open use because there's nothing between you. Even dispensing from the container, the squirt bottle, so dispensing from the container is open use. There's really nothing stopping it from getting out. So that should put an end to the histology labs, the large histology labs. On the waste question, since nothing changes about the material, the EPA's perspective notwithstanding, nothing about the material changes when it goes from being used to being waste. So there may be mixtures and there may be laboratory adjustments to the molecular structure, but flammable is flammable, poisonous is poisonous. And it's impossible to parse out how much of a material is flammable and how much of it is poisonous. If it's methanol, it's all flammable and it's all poisonous. And so it all counts to both of those MAQ standards. So managing, and then if you mix methanol with xylene, I don't know why you would, but if you did, you'd end up with a flammable, poisonous, larger volume because the poison is coming from the methanol. The xylene's not all that poisonous. So, the managing waste is it ends up, the only way to do that and still be safe in terms of fire response is manage your wastes very aggressively and move them out quickly, because you just don't want to stack up a bunch of flammable stuff next to the door of the lab. That's imprudent. So and then Jeff, you said one thing. I don't want to take the time to think about it. I'll think of it as soon as we're done. You had said one little thing about waste that
So let me add to this.
Get on, Lenny. Yeah.
So about
Lenny.
the fume hoods and being storage cabinets, that of course was answered no. That fume hood cannot contain a fire, right? If we had the fire in there with the flammables. So, but along those lines, there was a question about glove boxes and are they rated?
Mm-hmm.
DOE is probably the leader of Department of Energy is probably the leader of glove boxes worldwide, hundreds and hundreds and thousands of glove boxes. And I've never seen one that's rated. They have all the latex glove ports that you can put your hand through. They are not fire rated per se. They would be considered an enclosure, right? So, none of the air can get out. A lot of times they're inerted, but they are not fire rated and would not contain a fire for an hour, 2 hours, or 4 hours. So,
yeah, I'll add to that. There was a fire in a high bay at one of my former institutions, and it was from a glove box, and they're not rated as Lenny's saying. And all's well that ends well. No one was injured. No one was overcome by the smoke or the gases or anything like that. But to Lenny's point, yeah, absolutely. But I think this gets at the larger issue, John. Go ahead.
Can I just jump in quickly? Because I interviewed a fellow who worked at NASA during Apollo, and they built a box to contain the moon rocks while they were parsing them out and sorting them. And they built a system, it was a glove box, and they built a system in that box that would incinerate anything that so much as twitched. If they found out that there was actually something alive on the moon, they wanted to destroy it with fire. And then they had to put out that fire. He designed the fire suppression system for that glove box, which was designed to contain the fire. So Lenny, I agree. Y'all do a ton of glove box work.
Yeah.
but it is possible to build a fire rated glove box, but it takes a lot of work.
Specialty case.
Special. Yep.
And the other thing I would say is a lot of the DOE glove boxes are inerted, you know, and you know, that whole NFPA committee related to that is, you know, fighting over whether an inerting system inside that glove box is actually a fire suppression system or not. So there's a lot of differing views on that as well.
Mm-hmm.
So, though personally, I would always rather see an inerted glove box, because if you have a flammable material inside another glove box with air around it, I think that's how you build explosions. That could be a whole lot worse than not having a glove box at all.
I agree. Yep. Little bits of glove box flying across the room, almost supersonic.
Yep. And I've seen wide varieties of, you know, places where you're expecting the gloves to, quote, pop off, but then because the gloves fall off when you have the toxic material, that's not a good thing. So they start putting bigger and bigger clamps on the gloves to make sure that those gloves don't come off, which is when you now fail the entire glove box.
Yep.
Yeah. And it looks like we've answered a lot of the questions that we're able to. Some of the inventory questions we aren't able to really address here. And we're trying to address them as much as we can behind the scenes. Although, you know, inventory systems are really part of this. And if any of you guys want to discuss any aspects of that you have seen for trying to use them to your advantage or struggles with it, you know, certainly feel free to do so. I do have another area that we haven't gotten to yet. And so it really, a lot of the people on the Q&A and in the chat as well, and we're past the hour. So we know that a lot of people probably have to go, but if you guys are able to continue, we'll continue to do at least a little bit of the Q&A until at least quarter after. Oh, not at least, until quarter after, if you can stay, that would be wonderful. So good. So I think a lot of the discussion is these struggles, you know, about how do we involve people. And so one of the questions that the four of us discussed before was really, you know, what are the best methods? Where have you seen successes or lessons learned, failures in bringing stakeholders along and getting them truly involved throughout the process? And then along with it, you know, what do you do? How do you persuade people who might struggle to really understand the obvious to us now implications of these codes and the limits? Any tips, any techniques or don'ts, guys? And whoever wants to start.
Two that I go back to over and over and over again. These are basically an endless supply of wisdom. Fire codes especially, but most health and safety codes and even the EPA codes, maybe to an extent, are written out of bad experience. So very, very seldom will we change fire code just because we think it's necessary to change fire code. Often we will change fire code because a building collapsed or people died in the smoke or whatever. So these codes, the expectations in code are born out of loss and sorrow. And anyone who ignores the loss and sorrow that's expressed in those code does so in a way that will probably repeat the loss and sorrow and bring it upon themselves. So there's a great deal of wisdom written in these codes. And from my point of view, that wisdom is there to avoid disaster. The other side of this that I often will do is I'll ask people to consider possibilities. And I'm just going to show you what that looks like here. So we either make a plan or we don't, and we either have a problem or we don't. And I'm thinking, I think my screen is shared. Is that true?
Yep.
Yep.
So then all we do is, it's a yes or no question either way, right? You're either going to make a plan or not, and you're either going to have a problem or not. You're in control of whether you make a plan. You're not in control of whether you have a problem. And then you just write the headline and figure out how you're going to answer these questions and answer the questions to your stakeholders being your students' families, your government relations folks, your press people, your lawyers, your insurance company. Just answer the question. So if you make a plan and you need it, you're glad you had a plan. If you made a plan and you don't need it, well, it wasn't a total waste of time because you have a plan. If you didn't make a plan and nothing happened, you got lucky. And that fourth one if you don't make a plan and a problem happens, what are you going to do? And my answer as the fire marshal is, we're going to follow code. And if we don't follow code, then you're going to tell me what your plan is for not following code, because my answer is going to be, I told you to follow code. And ultimately, when we don't listen to the wisdom of history, we end up repeating history. And so, I mean, this is axiomatic to me right now. And my perspective is, we have to decide whether or not we're going to make a plan, because the problems are coming regardless. And if we decide that we make a plan, and that plan is, and we do good work making the plan, and it's still not sufficient. I mean, not every building can survive being struck by an airplane. Then okay, but at least we tried, and that's way different. So I put this into most of my conversations, and then also remembering that code is the accumulated wisdom of loss.
Thanks, John. Guys, adding to that?
I like that quote. Code is the accumulated wisdom of loss.
You're welcome to it, sir.
Thank you.
I've always heard that the codes are written in blood.
I use ashes and blood because I'm a fire guy, but yeah, same.
So anything to add to that, or shall I take on another question that we have here?
John did a great answer. Let's go to the next one. Yep.
Yeah. And I think that some of you guys are also typing your answers. So I'm not dismissing the questions, because I see that people are typing answers. So I don't want to dismiss it. It'll disappear. So I'm scrolling back and forth looking for any new ones. Dawn, I wanted to know, and it's recent enough perhaps to revisit this, meaning she asked it recent enough. Could we please talk about how to translate between chemistry and firefighter, or maybe between chemist and firefighter? And certainly I'm happy to chime in on this. This is an area that I tend to travel in a lot, but you guys know this really well. You often, I think, work in this space. How do you translate between what the researchers and scientists, technical people are saying, and then the fire departments, who are all very technical people, but they speak a very different language?
So I usually like to start out, and again, knowing your audience is important. So if you have the relationship ahead of time, you have a better feel for where the person's at. I mean, do they have some high school chemistry? Do they have, in some of our volunteer fire departments, do they have a master's in chemistry, or even a doctorate around here? We have on our volunteer fire departments. So understanding where they're coming from really can help you phrase the answer. But I like to go back to analogies, convert the chemistry that's going on to something that they may have within their experience set. Talking about, a phenyl group, hooked onto a methyl, phenyl methyl something, or, okay, that's really good chemistry, but being able to sit there and say, hey, this is a little less flammable than gasoline, or you're going to get a whole lot less complete combustion. You're going to get a lot more black smoke. You're going to get a lot more toxic compounds coming off of this. It's more like burning a couch with urethane foam insulation or something. But trying to come up with those analogies to get in at least the right ballpark for the hazards, the heat load, what they should expect when they're going in to try to do that fighting. And so I always try to draw some analogies to things that are in their wheelhouse where they can talk about.
Yeah. I'll add to that a few quick thoughts here for everyone. In-house, your own places, talk to whoever does training, especially if they've done any hazmat training. I think that was the most valuable for me. So my having to train fire departments and other responders in the DOT emergency response guide, the little orange manual, if you've got the hands-on one, I was going to get up and get it, but I think or you can find it online, and you'll quickly see what is it that they need to know and go to that. As Jeff's saying, how flammable is this? And for me, one of the best ways that's always most successful is I'm the safety guy for engineering. It's our building. Tell me what you want to know and I'll tell you, right? Or I'll find out. So let them guide you in what. So if they say, we want to know the chemicals, it is that basic. What are the chemicals? And you start with, well, we've got these various acids. Do you want to know what the different acids are? For not so much of a fire issue, but we had that classic issue of HF versus HCl. Hydrofluoric sounds like hydrochloric, and we call it HF instead of hydrofluoric because of the rhyme of the two. And literally in the building I was in, 7 o'clock at night, we had the fire department show up for an explosion. And they said, yeah, we got the report that you've had a hydrochloric explosion. And we went up there and sure enough, it was hydrofluoric, HF. And so it's like, what do you want to know? I can help you. Start with the big picture and then narrow down. When you start too detailed, which I think a lot of us scientific, technical people tend to do, focus minutely on details, you've got to start bigger picture. And guys, do you have things you'd like to add for tips on that?
So in my view, ultimately, on the fire ground, fire department's in charge. Fire department is asking questions to solve problems, and it's our job then to provide the information. And so that translation has to happen. If you don't have a PhD chemist on your fire crew, the people you have weeks and weeks and weeks of training, and then they have years and years and years of experience dealing with hazmat fires, but of a different kind of a scale than you see in a laboratory, a different level of complexity than you see in a laboratory. And if you don't have anybody between the firefighter and the chemist, then you may end up with that dissertation and coming from the chemist, which is just stop, you're wasting time. Let's get this down to more basic. I think we need to know at least as campus fire marshals, we need to know generally what's happening in the space. And we need to understand it in terms of the science. So if they tell me we're doing histology, it doesn't really matter what they're doing histology on. I know what histology is. I know what general hazards that presents. And because I've been through the training, I understand from a firefighter first responder what that means and what's relevant here. What's relevant here is downrange distance, isolation areas, offensive, defensive operations. How do we clean up the stuff that we put on it when it's on fire? And how do we get people clean and turfed off to the hospital if they should become patients? Those are the kinds of things that the fire department's asking about. They're not really interested in hearing you defend your dissertation, or that's not really what they're asking for. It might be what you think they're asking for, but they're not. They're asking very operational questions, and we need to give them very operational answers that are true, but shave off a ton of the detail because they have to be delivered quickly. Because guess what? When your lab's on fire, your research product is burning, and you can't unburn research. So we're trying to get that stuff resolved as quickly as possible. Detail doesn't really have a place unless it's important, like the HF hydrochloric detail. That's a very important detail because in hazmat response, there's basically a 50-to-1 scalar when you're dealing with HCl versus HF, in my experience.
Yeah.
The factors, all the factors, the pucker factor, the scare factor, all of that is much, much higher when you're dealing with HF.
All right.
John, you actually said one other thing that I think I'm just going to jump on real quick here.
Sure.
Also with this communication, slang and acronyms, because especially in the chemistry world, it's full of things where people take shortcuts, like Me2 for dimethyl dichlorosilane. We just call it Me2. That is way not going to help anybody on the responder side. And likewise, some of the terms that the responder is going to use in terms of their equipment and things may not make any sense at all to the researcher. So being real conscious about slang or terminology, and especially acronyms that could have different meanings even within different buildings is going to be a key thing.
Yeah, Jeff, you're absolutely right. So the difference between Me2 and methylsilane is if you say the word silane to a firefighter, a hazmat firefighter who's been through a rigorous amount of training, they instantly know what part of the field you're playing in. It's a very, very dangerous part of the field, and they get it. You tell them Me2, and they're just going to give you a look. Yeah. So it's absolutely right. There are key words that we need to project into the fire ground.
We've really hit the end in just a few seconds each. Any regrets, lessons, or things you'd have done differently looking back over the years? And I'll start with Lenny.
Yeah, I thought about this when you gave it. I don't know that I have any regrets. I always look forward. I think I made the right decision bouncing around my career, different jobs and stuff. But, most of my experience has all been with developing and maintaining and driving consistent fire protection programs. And so I've been lucky to be able to do that, and look forward to finishing my career here at Intel. So nothing that I would change, I don't think.
Awesome, that's great. Forward looking is always good. Jeff?
Probably the only thing that I would regret is that when I was really early in my career, I viewed the standards and the standard process as this big hurdle that I always had to go up against, and it was like running into a wall. And what I've realized over time is that the more involved and the more active participant in the process, getting onto the NFPA 45 committee, the Standards Council, being actively engaged on those things, there's reasons for this stuff. And there's opportunities that if you get involved with it, you understand it, you build the relationships. John and I have just sat through 3 days of meetings earlier this year, because this is how we get to know each other. This is how we make the standards better. And it's how we protect more people. So it's not that these things are this wall that you run up against. It's, hey, there's this opportunity. Let's all go grab onto the rope and pull it together and go in the right direction.
Cool. And lastly, John.
Yeah, John, like Lenny, I try not to live a life of regret. There are some things that I would tell my younger self, but I know that my younger self wouldn't listen. But one of those is exactly what Jeff said, get involved earlier. And the other one is something that I now hold to be true, that these are not codes. These codes are not just words, and they're not just a compliance exercise. This is a sacred trust. And it's different. I used to do EPA stuff, and EPA stuff is just regulatory compliance. There's no sacred trust there. The sacred trust that's in fire code is we have these codes because people died. And if we want to revisit that experience, by all means, ignore the wisdom. But from my point of view, having worked fatalities and having worked fires, the fewer of these that I can do, the better. I'm right there. When you're young, it's exciting to work these problems. Maybe not the fatalities as much as the fires, but it's exciting to work the problem. But I would much rather put my money on preventing the problem and not having it in the first place, and saving all those lives, because the cost of that goes on forever.
Yeah, it really does. Well, I've just got to say thank you to you three guys. It's been wonderful. And I've learned so much, not only in our discussions but today too. And of course, thank you to our audience. We're still at like 138 to 140. And we're at 18 after the hour. I would have to say that's absolutely a testament to how valuable your time and your input and your knowledge has been, and your willingness to answer all of these questions. The complexity of something that I think I will say I oversimplify as, oh, it's just fires. How complex can that be? And you start to look at all of the different codes, and then all of the different questions that we all have, this situation, that situation. It gets right back to what the guys said to me, Jonathan, please let us talk about how valuable it is to involve people way before and throughout, and how important it is to develop such a wonderfully close working, and I'll say friendship, great relationship with the fire service and fire marshal offices. Everyone's there to get the same thing. It's, as the three guys have said, how do we keep people safe? How do we prevent the tragedies that these codes have been written in? And this has been great. Thank you all so much for just such a wonderful time.